Welcome to episode 1 of this series where we explore the hidden architecture of reality through the lens of numbers. In this episode, we begin with a question that seems simple, but is actually one of the deepest questions in human thought. What is a number? Where did it come from? And why does it shape everything from ancient calendars to the structure of the universe? According to G.H. Hardy, in his book An Introduction to the Theory of Numbers, numbers are the raw machinery of existence and the absolute truths that lie beneath the shifting patterns of the physical world. This video is not based on any textbook. It is part of my personal research into how numbers evolved and why they matter. Today, we begin a journey that stretches from prehistoric caves to quantum physics and the birth of the cosmos. Thor. The story of the word number is a journey through language as much as it is a journey through mathematics. The English word number comes from the Latin word numerus, which meant a count or a quantity. But the roots go even deeper. Linguists trace numerus to the Proto-Indo-European root nem, which meant to assign or to distribute. This suggests that the earliest meaning of number was not simply counting, but organizing the world into meaningful portions. As Latin evolved into Old French, the word became nombre, and from there, it entered Middle English as nombre, before finally becoming number. The evolution of the word mirrors the evolution of the concept itself. Early humans did not think of numbers as abstract symbols. They thought of them as tools for dividing, sharing, and understanding the world. Over time, the meaning expanded. Number came to represent not just quantities, but patterns, relationships, and structures. According to linguistic historians, the transformation of the word reflects humanity's shift from practical counting to abstract reasoning. The word number carries within it thousands of years of human thought, showing how language and mathematics evolved together to shape our understanding of reality. Numbers did not appear suddenly. They emerged slowly as humans tried to understand patterns in nature. This foundation will guide every future episode as we explore how numbers evolved into the language of science and the universe. From here onward, each episode will build on the last, revealing how numbers became the most powerful idea humanity ever discovered. To understand numbers, we must first understand what they represent. G.H. Hardy described numbers as the raw machinery of existence. Ancient Greek philosophers believed numbers were not invented but discovered as if they were woven into the fabric of reality. According to the book Nature's Numbers by Stewart. A number is not merely a symbol but a way of capturing patterns that repeat across nature, from the spirals of galaxies to the rhythm of a heartbeat. Modern physics deepens this idea. To a quantum physicist, a number is not just a quantity, but an operator, a tool that reveals the hidden symmetries of the universe. According to NASA, numbers define everything from orbital mechanics to cosmic background radiation. Numbers are not passive labels. They are active descriptors of the universe and its behavior. In modern physics, numbers are the language of reality. They define the mass of particles, the strength of forces, and the curvature of space-time. When NASA models the orbit of a spacecraft or the expansion of the universe, it relies entirely on numerical relationships. Numbers are not decorations. 2. Without them, we could not describe the behavior of electrons or the motion of galaxies. Numbers reveal the hidden order beneath the apparent chaos of the universe. The story of numbers begins long before writing or civilization. Archaeologists discovered the lebombo bone in southern Africa dated to around 43,000 years ago. It carries 29 deliberate notches arranged in a pattern that suggests early humans were tracking lunar cycles. Many researchers believe the earliest mathematicians may have been women monitoring biological and environmental rhythms. This marks the transition from instinctive quantity perception to intentional symbolic counting. Another artifact, the ishango bone, dated to around 20,000 years ago, contains patterns that may represent doubling or prime numbers. These early tools show that humans were not just counting. They were observing patterns in nature and encoding them into marks. This was the first spark of numerical thought. Early humans used simple counting systems based on physical objects. Stones, sticks, knots. Each object represented a quantity. This method was intuitive, but limited. It worked for small numbers, but became impractical for large quantities. Over time, humans began carving tally marks into bones and wood. Each mark represented one unit. This was the beginning of symbolic counting, but it was still tied to physical representation. The leap to abstraction had not yet occurred. These early systems show that humans were developing a sense of quantity long before they developed writing or agriculture. Counting was a survival tool used for tracking food cycles, seasons, and time. As societies grew more complex, numbers evolved independently across the world. In Mesopotamia, the Sumerians developed one of the first formal numeral systems, around 3400 BCE, using clay tokens and cuneiform marks to track trade, grain, and labor. Their base 60 system still influences modern timekeeping and geometry. In Egypt, hieroglyphic numerals emerged around 3000 BCE, enabling land measurement, pyramid construction, and astronomical observations. In the Indus Valley, standardized weights and measures reveal a sophisticated understanding of quantity and ratio. In China, oracle bone inscriptions from the Shang dynasty show early numerals used for divination and administration. In Mesoamerica, the Maya developed a base 20 system and one of the earliest uses of zero. These cultures never met. Yet each discovered that numbers were essential for trade, astronomy, and survival. 2. The shift from tally marks to symbols marks, one of the greatest cognitive leaps in human history. A numeral such as 7 is a symbol, while a digit is the fundamental building block of that symbol system. This abstraction allowed humans to move from counting sheep to calculating distances between stars. According to the book The Universal History of Numbers by Georgia Sifra, every culture reinvented numbers because the need to quantify reality is universal. This leap to abstraction allowed humans to think about numbers without needing physical objects. It opened the door to arithmetic, geometry, and eventually algebra. Numbers became ideas rather than objects. Room. One of the most important milestones in the history of numbers was the invention of zero. The Babylonians used a placeholder symbol, but not a true zero. The Maya independently developed a symbol for zero in their calendar system. But ancient India transformed zero into a true number with its own rules. Texts such as the Bukshali manuscript and works by Brahmagupta formalized zero and negative numbers, enabling algebra and advanced arithmetic. Zero was not just a placeholder. It became a concept representing nothingness and potential. This idea later spread through the Islamic Golden Age, where scholars such as Al-Khwarizmi refined algebraic methods. These numerals eventually reached Europe and became the digits we use today. The invention of place value transformed mathematics. In a place value system, the position of a digit determines its value. This allowed humans to represent large numbers efficiently. The Indian numeral system combined with zero created a powerful framework for arithmetic. When this system spread to the Islamic world and later to Europe, it revolutionized trade, science, and engineering. Place value made calculations faster and more accurate. It allowed mathematicians to develop algebra, geometry, and calculus. Without place value, modern science would not exist. Ancient civilizations used numbers to track the movement of stars and planets. The Babylonians recorded astronomical observations for centuries, creating detailed tables of planetary motion. The Egyptians aligned pyramids with celestial bodies. The Maya developed a complex calendar system based on astronomical cycles. These early astronomers used numbers to predict eclipses, seasons, and celestial events. Their work laid the foundation for modern astronomy. Numbers allowed humans to understand the rhythm of the cosmos long before telescopes existed. Architecture is one of the earliest fields where numbers became essential tools. The Egyptians used precise measurements to construct pyramids. The Greeks used ratios to create harmonious temples. The Romans used geometry to build arches and aqueducts. Numbers allowed architects to design structures that were both functional and beautiful. They calculated angles, loads, and proportions. Without numbers, these architectural marvels would not exist. Numbers transformed human creativity into engineering. Trade was one of the driving forces behind the development of numbers. Merchants needed to track goods, measure quantities, and record transactions. The Sumerians used clay tokens to represent commodities. These tokens eventually evolved into written numerals. In the Indus Valley, standardized weights ensured fair trade. In China, early numerals were used for taxation and administration. Numbers allowed societies to manage resources, coordinate labor, and build economies. They were not abstract ideas. They were practical tools for survival. Numbers have played a significant role in religion and mythology. Many cultures believed certain numbers had sacred meanings. The number 3 appears in many mythologies. The number 7 is associated with cycles and completeness. The ancient Greeks believed numbers revealed the harmony of the universe. The Maya used numbers in their cosmology and rituals. Numbers were seen as bridges between the human world and the divine. They were symbols of order in a chaotic world. Greek philosophers transformed numbers from practical tools into abstract concepts. Pythagoras and his followers believed that numbers were the underlying structure of the cosmos. They saw numerical ratios in musical harmony, geometric forms, and celestial motion. This philosophical shift laid the groundwork for mathematics as a universal language. According to Ian Stewart, Greek mathematicians were among the first to treat numbers as objects of pure thought rather than mere counting aids. Their work influenced centuries of mathematical development. 2. The Greeks developed geometry as a logical system based on axioms and proofs. Euclid organized geometry into a structured framework that became the foundation of mathematics for over 2,000 years. Numbers played a central role in this system. They were used to measure lengths, angles, and areas. Geometry showed that numbers could describe space itself. This connection between numbers and geometry would later influence physics, astronomy, and engineering. 2. The Islamic Golden Age, scholars preserved, expanded, and refined mathematical knowledge. They translated Greek, Indian, and Persian texts into Arabic. Al-Khwarizmi developed algebra and introduced Indian numerals to the Islamic world. These numerals later spread to Europe through trade and scholarship. Islamic astronomers used numbers to calculate planetary motion and develop new instruments. Their work bridged ancient mathematics and the scientific revolution. Medieval Europe, mathematics was preserved in monasteries and later taught in early universities. The introduction of Hindu-Arabic numerals transformed commerce and science. These numerals were easier to use than Roman numerals and allowed for more complex calculations. Merchants adopted them for bookkeeping. Scholars used them for astronomy and geometry. Numbers became tools for exploration and discovery. 3. The scientific revolution transformed numbers into the language of natural laws. Galileo used numbers to describe motion. Newton used calculus to explain gravity. Kepler used numerical ratios to describe planetary orbits. Numbers became the foundation of physics. They allowed scientists to create models, predict outcomes, and test theories. The universe was no longer a mystery. It became a system governed by numerical relationships. The Industrial Age brought new applications for numbers. Engineers used mathematics to design machines, bridges, and engines. Statistics emerged as a tool for analyzing data. Probability theory became essential for insurance and finance. Numbers allowed societies to manage large populations and complex systems. They became tools for planning, production, and measuring progress. The Industrial Age showed that numbers could shape economies and transform societies. The invention of computers revolutionized the role of numbers. Binary digits became the foundation of digital communication. Computers use numbers to process information, store data, and execute instructions. Algorithms rely on numerical operations. The digital world is built entirely on numbers. Every image, sound, and message is encoded as numerical patterns. Numbers became the building blocks of modern technology. Modern science relies heavily on numbers. In chemistry, numbers describe atomic structure and chemical reactions. In biology, they model population growth and genetic variation. In physics, they define the behavior of particles and fields. According to CERN, the universe at its smallest scales is governed not by certainty, but by probability, and numbers are the language of probability. Numbers allow scientists to test hypotheses, analyze data, and make predictions. They are essential tools for understanding the natural world. Cosmology uses numbers to describe the structure and evolution of the universe. The Hubble constant measures the expansion rate of the universe. The cosmic microwave background reveals temperature variations that shaped the formation of galaxies. Dark matter and dark energy are defined by numerical models. According to NASA, numerical relationships shape everything from orbital mechanics to cosmic background radiation. Numbers allow cosmologists to explore the origins of the universe and predict its future. Quantum mechanics uses numbers to describe the behavior of particles at the smallest scales. Wave functions assign probabilities to different outcomes. Operators determine how particles interact. Energy levels are quantized, meaning they come in discrete numerical values. Numbers define the structure of atoms and the behavior of electrons. Quantum mechanics shows that numbers are not just tools for measurement. They are fundamental to the nature of reality. Numbers play a central role in everyday life. They guide navigation through GPS. They manage finances through banking apps. They measure health through medical devices. They power communication through digital networks. Numbers are embedded in every aspect of modern life. They are invisible yet essential. Without numbers, the modern world would not function. Numbers are both a human invention and a discovery. Humans invented symbols to represent quantities, but the relationships those symbols describe exist independently of us. The ratio of a circle's circumference to its diameter exists whether or not we write it down. The patterns in nature exist whether or not we observe them. Numbers reveal the structure of reality. They're tools for understanding the universe and reflections of human curiosity. Numbers reveal something profound about humanity. They show that humans have always sought patterns, meaning, and order in a chaotic world. From ancient tally marks to quantum equations, numbers reflect our desire to understand who we are and where we come from. They are the quiet thread connecting prehistoric caves to particle accelerators. Numbers remind us that knowledge is a continuum, not a destination. They show that the universe is not random but structured, and that humans have the ability to uncover that structure. Numbers are the language through which the universe expresses itself. They describe the motion of planets, the structure of atoms, and the evolution of galaxies. When we say that a planet orbits a star, we are describing a numerical relationship between mass distance and time. When we say that light bends around a black hole, we are describing a numerical curvature of space-time. According to NASA, numerical models allow us to simulate the birth of stars, the collision of galaxies, and the expansion of the cosmos. Numbers are not just tools for scientists. They are the grammar of reality. Every natural law can be written as a numerical equation. Every physical phenomenon can be measured, predicted, and understood through numbers. This is why physicists often say that mathematics is the language of the universe. It is not poetry. It is structure. It is not metaphor. It is mechanism. Numbers reveal that the universe is not chaos, but an ordered system governed by relationships that can be expressed with precision. When we study numbers, we are not studying human inventions. We are studying the blueprint of existence. Stewart. Thank you for joining me in episode 1 of this exploration into the origins and meaning of numbers. We have traveled from prehistoric caves to the edge of the universe, discovering how numbers evolved from simple marks on bones into the language of reality itself. Numbers shape our world, our technology, and our understanding of the cosmos. They reveal the hidden structure behind everything we see and everything we are yet to discover. This journey is only beginning. In the next episodes, we will dive deeper into the evolution of mathematics, the mysteries of zero, the rise of algebra, and the numerical patterns that govern the universe. If you found this episode inspiring and want to continue exploring the foundations of reality, please subscribe and join me for the next chapter. There is so much more to uncover, and I look forward to exploring it with you.